Hi there, my name is Mark, and today I'm going to be sharing with you my org-roam workflow for capturing mathematical content. Now I'm going to be upfront right from the beginning. There's going to be no programming today, so no Python, no LaTeX, no Emacs. It's just going to be a straight up overview of what files are being created and a little bit about the nomenclature of those files. Now, since this is pertaining to the schema of mathematics, LaTeX is the core of the content that's being generated. I've also invested over 20 years in creating content using LaTeX, so it's just a natural choice. And now with large-scale language models being all the rage, I think it's only going to be more important in the future. Now, how do I organize all this? Well, I am a huge fan of Emacs and org. In fact, I used to store all of this data inside an org table, and then I discovered org-roam. So org-roam is going to be essentially the database that I'm using to organize all this content. So today we're going to be looking at the relationship between the content stored in the LaTeX files and these org files, which is essentially my database. Now, for me, LaTeX needs to be a modular system for it to work. And what I mean by modular is when I add new information to my Zettelkasten, it is going to be a specific node of information, and I want to be able to propagate that node depending on the context. So maybe that information I want to include it in a slide deck, or maybe in one of my notes, or maybe even in an exam. So I want to be able to make a change in one file and have those changes propagated to all those files that reference it. Now, I did say there would be no programming today, but I did want to give you an overview of how this script is working. When the script is run, the interpreter will create the necessary org-roam file and all the supporting LaTeX files depending on the type of information that's being input into the system. The first thing that's going to happen is the terminal is going to get cleared, and then a tag ID is going to either be manually created or automatically generated. Next, I will be prompted for what type of information is it? Is it a definition, an example, a theorem, a proposition? Maybe it's even a TXT file or a Python script. Now, once we've chosen the type of information we are going to be inputting into the system, the appropriate files will be created. And then the tag ID is removed from the stack, and we're ready to start populating those files. Now, let me give you an overview of what files are created. Of course, there is an org-roam file created automatically. It's also assigned a unique UUID, a date, and a title, just like most other capture methods. Now, in addition to that, though, we have all these supporting LaTeX files generated. And all of these files are going to be assigned that unique 4-character alphanumeric ID code. Now, those tex files to the left, these are structural files. And by structural files, I mean it is a template used to build possibly a slide or a note or an exam problem. But there's no content in these structural files. All the content is stored in what I refer to as core files. So here I would actually write the content within these files. And what's really cool here is that this core information can then be pushed into a variety of different templates, such as a slide or a note. So write it once in the core file and have it propagate to all the different structural files. Now, in the event that it is a problem that's being created, then I will have the core exam files created, and this allows me to store marks for different problems in different curricula and even different mark schemes. So now that we have the structural files and the actual content, I need to be able to put these in actual documents. And these text documents, it might be a slide deck where I can input different slides. It might be my notebooks where I can import notes, and it might be an exam where I'm importing those exam files. Now, what's really cool here is this is super modular. So for example, any slides that I've created, I can import those in multiple slide decks. And if I need to make a change, I make the changes in the core files and it gets propagated to all the different content files. Super fantastic. Now let's go back to thinking about those org files. It is also possible that I have created just an org file manually using just a normal capture method in org-roam. So maybe I'm creating a map of content where I'll be able to link those automatically generated org files. And in addition to that, I can also link those tech files within these manually created org files. And this is super convenient when you're creating exams, because you'll be able to see which questions have been used and how often and in which exams. And that's just one use case. Now, I do want to talk about one more thing in terms of the files being created, and that has to do with assets. Now, I have a separate folder on my system for all kinds of assets, mostly images. Now, these could be TXZ images, Python images that are automatically compiled, and they're ready to go as PDFs that can be imported into the core files. And this serves as an optimization for compilation a little bit later in the system. Now, in addition to that, these assets can be imported into org files, and mostly this is done as PNGs. And these PNG files are automatically generated using another script. Now, this Python script is going to need an entire video devoted to itself, because it is used to decide which tech files need to be compiled or recompiled. And in addition to that, it is used to generate the PNG files for all of those TXZ images and Python images, and the first slide of every single structural slide file. And that will allow me to reference those slide images within OrgRoam to get a really quick idea of what is contained within those tech files. Now, we are talking about the schema of mathematics, so I do want to talk a little bit about the file nomenclature that I'm using within OrgRoam. Now, we do know that that Python script we looked at earlier is generating the OrgRoam file and all the supporting LaTeX files. So these org files captured into OrgRoam are a bit special because they belong to a specific schema that I have given specific hierarchies of where information lives within this schema. In addition to that, I also provide all my files that belong to the mathematics schema a classifier. And that just tells me, is this information a definition, a proof, is it a theorem, what is it? And then, of course, it's going to have that unique tag ID. So for example, when the OrgRoam file is created, we give it a hierarchy of where it's located within the schema. In this case, it is mathematics, calculus, differential calculus, rules, polynomial, binomial, degree n. So I have an idea of what's located inside this file. I also have my classifier, which is solution. So I know it's a written solution to a problem, and then that tag ID. Now, really, I only need the tag ID to create the file name. However, I also want to be able to provide myself a little bit of insurance in terms of future proofing. So let's take a look at my schema file, which stores all of these hierarchies of information. So for example, here we have a hierarchy of information. Now it's really cool, during the execution of that Python script, it will prompt me for a schema. And all I need to do is give it a query for a particular hierarchy. It will parse this org file and give me the top 10 results. Otherwise, I need to add it to the file, and I just do that manually because it's just a plain org file. And that will generate a org file within my Zettelkasten. And that's pretty much it. My name is Mark. Thank you for watching, and happy teching.